Good morning, students. In this video session, I am going to teach about the simple strategies for developing an algorithm. So, strategies means what are the techniques, what are the methods we are going to develop or we are going to use for the development of algorithm. Okay, that is the simple strategies. First, we have to see some of the steps. What are the steps required? Then we can go for the strategies. Okay, so steps required for developing algorithm is first you have to, what is algorithm? First you have to find the solution, right? It's a step by step description to find the solution. So first you have to know about the problem, right? That's the first step. Obtain the description of the problem. Okay, before developing an algorithm you have to know the clear sketch about the problem. What's the problem? First you have to know. Okay, you have to get all the information. Then analyze the problem. Second step is analyzing. So analyzing means you are gathering all the information and you are trying to get the steps to find the solution. That is analyzing. Okay. Third step, only you are going to developing. First, get the clear description, then analyze how to find, then you have to develop the algorithm, high level algorithm. What's the fourth step? After developing the algorithm, you have to tune up it, right? You have to make it as a simple thing. You have to make the algorithm as efficient. How you find the efficiency of the algorithm? By using three things we can find, right? What are the three things? 3 to 4 things. One is time. The algorithm want to take less time. The algorithm want to take less memory. Then, what's the next thing? The algorithm should be in the order. The algorithm must be accurate. Okay, the main three important thing is accuracy, time, memory. The fourth thing is order. Okay, so depend upon that efficiency qualities, we have to refine your algorithm in the cleaner manner. Okay, the last one is review the algorithm. You have to check your algorithm whether it is giving the proper solution, whether it is giving the finite solutions or not. Okay, these are the 4 steps we have to use for developing the algorithm. Now strategies, what are the techniques, what are the methods we are going to develop the algorithm means 4 strategies are there. What are the 4 strategies means? The first one is top-up approach. The second one is bottom-up approach. The third one is iteration and the fourth one is recursion. These are the 4 strategies which is used for developing the algorithm. We will see one by one. Okay. The first one is bottom-up approach. First, I will tell the definition. What is bottom-up approach means? For one complex problem is there. Okay, one big problem or complex problem is there. The problem is divided into smaller problems. Then again the smaller problem is divided into smaller sub-problems. Okay, see the diagram here. First, this is the function or this is the module. This complex module is divided into 2 sub-modules. Again the sub-modules is divided into another 2 sub-modules. If you say a simple example means you want to put the admission in the school or college. First you will go and see the principal, okay, requesting for the admission. Then you will pay the fees and everything in the account session. So first principal, then accounts department and your head of the department. Then you will go to the classes, then your library. Like that, the big task will be divided into smaller tasks and each task will be executed from the topmost. The most complex will be divided smaller modules and each thing will be thing will be completed individually. Then you will get the clear sketch solution. This is the top down approach. The second one is bottom up approach. The same reverse process. The reverse process to top down approach. All the important things and the concrete things and the base things will be completed first. Then it will solve the other things. For example, see, it's a reverse process. Consider a class. You are taking lot of leaves. Okay. So these ABCD are the students. Okay. Many problems are there. Then it is, if you are taking lot of leave means what the next step? You have to meet the class coordinator. Then again the problem is not solved means you have to meet the HOD. Again the problem is not solved means you have to solve the principal. Like that, the basic things and the concrete important things should be solved first. Then the sub-modules should be merged as the modules. Again the modules will be merged as the another modules. Okay. First the base things will be solved, then it will be combined together. Okay. This is the difference between modules and bottom up approach and the top down approach. All of you got it? What is top down and bottom up? Next we are going to see about one of the important strategy called iterations. Already I explained in the building blocks algorithm also. Okay, building blocks of algorithm also. So what is iteration? The other name of iteration is looping. The other name of iteration is repetition. If you want to repeat anything many number of times, we are going for the iteration or looping. Looping or iteration is nothing but you want to repeat the set of instruction again and again for n number of times, or again and again till the condition is false. Okay, executing one or more statements or executing set of statements for specific number of times or till the condition is false. Okay, so where we are using loop? Whenever you want to repeat the set of instructions again and again, we for the looping statement. Now we can see one example, so you will get the clear idea about the loop. See what the example here? The example is you want to print the number 1 to n. Okay, so for example here 1 to n, right? Print 1 to n. So your starting position is 1. Start is 1 and end is n. Right? So here I am going to use the while loop. One type of iteration I am going to use. Okay. So I want to print 1 to n. For example, my n is 5. So till 1, 2, 3, 4, 5 I want to print this. Right? For that only I am going to write the algorithm. So what the first step? First step is you have to start the algorithm. Second step is read the value of n. What's the required to find the value of n? N is nothing but your n point. In the question it was mentioned as n. N means as the user you want to give the n value. So I am getting from the user. Read the value from the n. Okay, your n is nothing but ending point where you have to start. My n value is 5. Then set the value I equal to 1. Why we are using setting the value I equal to 1? Your ending point is n. Similarly, you want to start from one position, right? As per your question, where you have to start? You have to start from 1 to n. So you have to print 1 to 5. So I am considering this 1 as I. That's what I am setting the value, assigning the value. Set value I equal to 1. So this I denotes the starting position and n denotes the ending position. All of you got it? So while you are going to the loop, while you are using the loop, depend upon the question you have to think it. I want to print 1 to n. So my starting position is 1, my ending position is my n value. That's what I am using I value and n value. Now I am going to use the looping concept. As per the looping concept, what the steps are there? Initialization, condition, increment or decrement. Here I completed the initialization. See, I equal to 5, then n equal to 5. Initialization got over. What's the next step? We have to check the condition. Okay, so I am writing the condition here. Repeat steps 4.1 and 4.2 until I less than n. My condition here is I less than n. That means, what's I value now? 1 less than 5. Whether this condition is true or false. I less than equal to n. As I want to print till the last value, I want to put less than equal to. I want to print till 4 means less than. I want to print here till 5. So I am using less than 5. Okay. Whether this condition is true. This condition is true. If the condition is true means, this condition is true means, you have to repeat 4.1. What's the 4.1? Print the value of I. What's the value of I here? I equal to 1. So I am printing 1. Got it? What's the next step? Increment. If you are not increment, why I am using increment here? I want to make the I value to 5. Otherwise your loop cannot be terminated. It is a infinite loop. Okay, I want to make the I value equal to 5 at one point of time. For that only we are using increment. So increment is I equal to I plus 1. Okay. So what's the I value now? Now the I value is 2. 2 less than equal to 5. Condition is true or false? Condition is true. So again it will print the value 2. Again increment. Now the I value is changed as 3. Again the condition is true. 3 less than equal to 5. So it will print 3. Again increment. So what will happen? So what will happen here? The condition is true. So the I value is 4. So 4 less than 5, it will print 4. At last, again increment. So the I value become 5. So 5 less than equal to 5. Condition is true. So it will print 5 also. What's the next step? Again increment. Again while you are incrementing, the I value reaches as 6. Now what will happen? 6 less than equal to 5. Condition is false. Once the condition false, it will terminate the program. All of you got it? First, what's the need of initialization? For specifying the starting position and for specifying the ending position, we need the initialization and input. Then we are checking a condition. Whenever the condition is true, we have to repeat these two instructions. See here, these two instructions, this thing and I equal to I plus 1, increment. I equal to I plus 1. How many times I incremented here? Nearly 5 times. 5 times I repeated these two statements. 4.1 and 4.2, I repeated 5 times. This is iteration. If you want to repeat set of statements again and again, yes, n number of times or specific number of times, or till this condition false, we say it is a iteration. All of you got it? Okay. The next important strategy is recursion. What is recursion? If you want to know the recursion means you want to know the function concept. First I will tell what is function. I will give some examples. Then I will go to explain the recursion. The recursion and functions you will study in the 3rd unit also. Okay, here you are going to see the introduction. Okay, so function is nothing but, first function. Function is nothing but set of instruction to do a specific task. What is that? Set of instruction. That is nothing but set of statements. Okay, set of line code for doing a particular task. For example, A equal to 5 and B equal to 5, C equal to A plus B, print C. Here I am assigning A value is 5, B value is 5 and C value equal to A plus B. 5 plus 5, 10. Now print C. Okay. So what will happen here? These are the set of instruction. These are the set of statements used to do addition. Okay. Suppose in your program I want to perform addition 10 times. In your program you have to do addition 10 times. What will happen? You have to write these 4 lines. You have to write for 10 times again and again. So to avoid these things, they introduce the function concept. Okay, introduce the function concept. Inside the function concept, 3 elements are there. Inside the function concept, 3 things are there. One is function definition, then function call, then main program. Okay, the function program, you have to know What is function definition, function call, and main program. Okay. So for three things, right? So here function definition means you are giving the name to the function. I wrote 4 lines, right? For that 4 lines I am giving one name, add. In your programming languages, any variable comes along with open close parenthesis, we consider it as a function. Any variable name comes along with open close bracket, we can say it is a function. Okay, so this is the function. Then here I am writing a equal to 5, then b equal to 6. Okay. Return C. So this is one of the example for the function definition. For denoting the definition, I am using in Python one keyword is there, def. So I am using here. As you are going to learn Python, I am just give the example as a Python code. Okay. So def denotes the function definition, and this is the function name, and this is called as parameters. This is called as parameters. It's nothing but variables used inside the function definition. Okay. So this is the addition code. Okay. Now I want to do for 10 times. So in the main program, I am just in the main program, see here, x equal to 10, y equal to 5, and z equal to x equal to 10, y equal to 5, z equal to add of x comma y. So this is the main program, and this is the function definition. See here, inside the main program only always the function call will come. See, add of the same function name with 2 parameters is called as function call. The same function name without a definition, it comes in the function comes in the main program, means we say it is a function call. Okay. See here, add brackets, inside the brackets here a comma b, here x comma y. Here 2 parameters, here 2 arguments. Here 2 arguments. Okay. How the program will be executed means these things cannot be executed till the function call executed. Function definition should not be executed till the function call executes. Till the function call executes. All of it clear? So this def to return cannot be executed till this line executed. Okay. These 3 lines cannot be executed till the interpreter executes this line. Is equal to add, because this is the function call. So once this line executed, what will happen means the flow will come here. First x value equal to 10, y value equal to 5, then z equal to add of, what's the x value? What's the x value? 10 comma 5. That 10 comma 5 will be mapped here. Okay. The x value is mapped here and the y value is mapped here. Now what's the addition? C equal to 10 plus 5, 15. Return C. Here the answer is 15, right? 10 plus 5, 15. Return C. Where it will return? From where it was called, there it will be written. Return statement is used to return where it will be called. So the return C will be returned back this place. So what's the Z value now? 15. Here we can use print Z. Suppose again you want to call. Okay, so A equal to add of 20 plus 20 comma 30. 20 comma 30. Now what will happen? Instead of print Z equal to, A equal to add of now 30 comma 40. So what will happen? I no need to write again and again. From here again executed. So here the value is 30. Here the value is 40. 30 plus 40, you will get 70. The 70 value will be written back here. You can print A. This is the function concept. All of you got it? So in your function concept, you have to know about function definition, function call, and main program where it starts. Okay. Now we can see the recursion, so that only you can understand the recursion. What is recursion means? Function that call itself again and again is called recursion. Function that calls. Function. This is the function, right? Function definition. Function means function definition. Function definition that call itself again and again. Like iteration, this function definition is call again and again means we say it is the function, we can say it is a recursion. Okay. Function that call itself again and again, we say it is a recursion. Okay. Now we can see the recursion algorithm. Okay. So here I am going to use the factorial concept. Okay. What is factorial? Multiplication, right? For example, 5 factorial means 5 into 4 into 3 into 2 into 1. You will get an answer 120. What's a 1 factorial value? Your 1 factorial means the answer is 1. What is 0 factorial value? The answer is 1. For doing factorial, now I am going to explain the concept. Okay. So, using the now using this factorial example, I am going to explain the recursion concept. Okay. So first we will see one code. Okay. First, as per the algorithm, you are just starting the program. Start the program. Read the value. Only one input is required. That value is, for example, the n value is 5. The n value is 5. Read the value of n. The n value is 5. I am going to find the factorial for n. Okay. Then here I am using the function concept. That's what I am writing, call the function. So what's the function name here? Factorial of n. So it should be like this. See here, def factorial of n inside if n equal to def factorial of n equal to 1 or n equal to 0. Checking a if condition, return 1, else return n into factorial of n minus 1. Okay. So this is the definition part. And in the main program, n value, n equal to 5, factorial of n. Okay. This is the main program. This is function call. Okay. So the first step, start the program, get the input. What's the n value? N value equal to 5. Now call the function. What I already told in the function concept, function definition cannot be executed till this function call executes. Till its function call executes. So call the function f equal to, here we have to give one variable name, f equal to factorial of n. So what will happen? This statement will be executed. Factorial of n will be executed. What's the n value? 5. So here the value is 5. Now I am checking a condition whether the n value equal to 1 or 0. Whether it is 1 or 0? No. If it is 1 or 0, it will return the answer 1. Why? 1 factorial means 1. 0 factorial means 1. So it will return 1. Suppose other values, here the value is 5, right? So it will come here. Okay. Else return, what's the n value? 5. 5 into factorial of n minus 1. What is n minus 1? 4, 5 minus 1 is 4. Again, see here, what is this? The same function name without def is there. So what we can say it is here? It is a function call. Function call. What is recursion? Function that call itself again and again. Say this is the function. Inside the function itself, function call is there. That is the meaning of recursion. So this function call again till this stopping condition or base condition is false. Okay. Still this stopping condition or base condition is false. Okay. Now again, now what's the n value? 4. So here condition false, here it will come 5 into, now 4 into 3. Okay. Again you are passing 3. So what will happen? 3 into 2. The next step what will happen? 2 into 1. Again in the next step what will happen? 1 into 0. Now multiply this 5, 4, 3, 2, 1. You will get the answer 120. Okay. This is the way the recursion will work. Once again I will repeat. First step n value equal to 5. 5 into here you will get the 4. Again you are passing 4. So 4 into 3. Now you are passing 3 into 2. Then you are passing 2 into 1. Again you are passing 1 into 0. So what will happen? 5 into 3 into 2 into 1. Once the condition is 0, here the condition will be false. Okay. First n value equal to 5. 5 minus 1, 4. Then 4 minus 1, 3. Then 3 minus 1, 2. Then 2 minus 1, 1. 1 minus 1, 0. At that time, the condition will be false. See here, when n equal to 1 and n equal to 0, it will return 1. Okay. Where it will return? It will return back to the factorial. So the answer 120 will be returned back. That is f value. So you are next step you can print it. This is the recursion concept. That's the reason. First start, then read the value, then call the function. Okay, f equal to factorial. This is the function call. So once this call executed, it will come to the function definition. Inside the definition, you are checking a condition whether this n value, the n value is copied to this n value. Okay. So you are checking condition n equal to 1 or 0. If the condition is true, return once. If the condition is true, return once. Otherwise, you are checking this condition n into factorial of n minus 1. So it will be call again and again till the base condition is false. So these are the 4 strategies, simple strategies used in the algorithm. Okay. I hope you understand these concepts, students. Thank you.